right, so this one gets right into the nitty-gritty of the maths, which I like. So we're considering P as our variable. So if we had to find sigma squared, then that would have been NPQ, wouldn't it? Which is the same as N times P times 1 minus P, which is NP minus NP squared. I'm going to rewrite it the other way around. Negative NP squared plus NP. Which if we wanted to graph as a quadratic, oh no, I should have left it as NP, negative NP outside of P take 1. Because this means we're going to have so this is sigma squared, so that's like y, and this is P, so that's like x. So let's find the intercepts. So negative NP equals 0, which means P equals 0, which means an intercept is there. And P take 1 equals 0, P equals 1, which is another intercept. And how intensely do they want us to graph it? Do they want to know the coordinates of the vertex? Let me have a look at the work solutions. Nope. Oh yeah, well, it should be fairly easy for us to get the vertex, given that we know that if P is a half, then that's going to give us like the highest. All right, anyway, let's actually prove this. So, just wondering if I want to make it when the gradient is 0. Yeah. Turning point when sigma squared equals 0. So this is NP take N take 2 NP, which is N 1 take 2P. N does not equal 0, so 1 take 2P equals 0, so P equals a half, so is at the max. So it's going to kind of come through, pretend that I'd drawn that correctly. It's going to come through like that. Explain the symmetry of the graph. Well, in a binomial trial, in a Bernoulli trial, having P equals like 0.25 and Q equals 0.75 will give the same probability of, well, it has the same, yeah, Px equals x as P equals 0.75 and Q equals 0.25. We proved that a lot last exercise. 11c, show that sigma squared is less than NP, sigma squared is less than NQ. Well, I know 0 is less than or equal to P, and that's less than or equal to 1. Same with Q. Sigma squared equals NPQ. So that's times the number between 0 and 1, yeah? So NP is going to be less, NPQ is going to be less than NP, and NPQ is going to be less than NQ, because, well, P is less than 1, between 0 and 1, Q is between 0 and 1, So timesing something by a number between 0 and 1 gives you a smaller number. So sigma squared is less than NP, sigma squared is less than NQ. What else do we want? Show that the maximum value of sigma squared is n on 4. Oh, I like it. So sigma squared equals NP 1 take P. So it's at max when sigma squared is 0, when the derivative is 0. So that's NP minus NP squared. So that's N minus 2NP. So just like we did before, P equals a half, then NPQ at max is going to be N times a half, which is N on 4 at max. And question E, I hope I can fit this in like one line. Cannot. So, we've got sigma squared equals NP times 1 minus P, yeah? And the limit of sigma squared as P tends to 0 from above is N times 0 times 1 minus 0. So the limit as it comes down from above is 0. And then sigma would be the square root of 0. So sigma tends to 0. And it's going to be the exact same thing for P equals 1. So the limit as P tends to 1 from below is going to be the square root of N times, 1 times 1 minus 1. So it's going to be 0. Sigma is going to tend towards 0.